3.3 is going to be primarily on finding the derivatives of the inverse trig functions and working with those. But before we get there, we are going to start by just looking at a general form for the derivative of an inverse function. And so first I'd like you to think about what happens if you were to compose and form the composition of f inverse of x, let's say. And hopefully you remember that the defining property of inverse functions, that if you form either of their compositions in either order, you always get back to essentially where you start, I guess I'll say. So let's say back to x in this case, for any x. So let's work with this relationship and say, well, let's just go ahead and take the derivative of both sides with respect to x. So the derivative with respect to x of the right-hand side, of course, is just equal to 1. Now, the derivative of the left-hand side we can think of with chain rule. So we're going to have the derivative of the outside with the inside function left alone. So that would be f inverse of x. So f prime with the inside left alone. And then times the derivative of the inside. So f inverse, its derivative. So that's the derivative of the inside. So this is our chain rule at play here. So this f inverse prime is really what I am trying to come up with a form for the derivative of an inverse function. So we're just going to go ahead and divide both sides then by f prime of f inverse. So dividing both sides by f prime of f inverse. And so that's going to leave us with, on the left-hand side, we have f inverse prime of x is equal to 1 over f prime of f inverse of x. All right, so that is going to be how we can think about the derivative of a function, of an inverse function. So back up in my general form here, I have it at a I have it written kind of like for a specified value b. So f inverse prime at b is going to be 1 over what we just proved, f prime of f inverse of b. So that is our derivative of an inverse function. Now this b, like what am I talking about here? And I want to connect it with your book's notation. So one of the things I want you to kind of remember, and how we often write out a little fact here in dealing with functions and their inverses, is that if you have some point, let's say AB, that is on f, so if f of a is equal to b, so that's the same thing as saying AB is on f, you know, that is true, so this little statement is true, if and only if f inverse of b is equal to a. All right, so another way that you're going to see this all written here, so this is certainly a fine way to write it, and I wrote it this way just because it kind of connects more with just how I was writing out the proof, and it might be how you're more apt to see it in other books. But the other way, we can start to connect this with your book's notation by saying, okay, so that's all well and good. This is the same thing, my f of a equals b is the same thing as saying, so, or we could say if x0, y0 is on f, so if f of x0 is equal to y0, that is going to be true if and only if f inverse of y0 is equal to x0. So we could also write this, and we could say, just using this notation, f inverse prime of, instead of b, I could call it y sub 0, is equal to 1 over f prime of f inverse of y sub 0. So these two obviously are the same thing. Now, f inverse of y sub 0, so that is really equal to x sub 0. So this f inverse of y sub 0, that would equal x sub 0. I know this is just a whole lot of notation, almost feels probably like meaningless notation to you at this point, but I'm trying to connect this then with your book's notation. So if you kind of go down here then, so what you're going to see is kind of going from this notation and then heading on down the line here to how your book is going to denote this. Okay, this is more how your book is denoting it. So this 1 over f prime of x sub 0, that's your connection. So that right there with what I had written up above. So the only thing that's really different then if you kind of read through this is your book isn't using the f inverse notation. They're just kind of simply saying that f inverse is equal to this g function. So they're just basically saying in this g right here, they're just saying this is your f inverse function. And so that means then when you get to g prime, this is really saying f inverse prime. And so now you can see, you know, you have the exact connection with what I have written up above. So I just want you to see these two are exactly the same thing. It's just in most of the problems in this book, they take the extra step to actually say, suppose that f and g are inverse functions every time rather than just using the f inverse notation. Okay? So just a couple of different ways to denote the same little thing. So let's just take a look at an example. We're not going to have a ton of these anyway. I feel like I've already spent more time on this than I really needed to. So we'll look at a couple of examples. So suppose we have let f of x equal the square root of 4 minus 3x. And let's just simply observe, I guess I'll say, that f of negative 4 is equal to 4. And I want us to find f inverse prime at 4. All right, so again, in your book, they may say, suppose that f and g are inverse functions, and then they would say, maybe find g prime at 4. They would just kind of describe it that way. But I kind of prefer just saying it this way here. The square root kind of got out of control up there, didn't it? All right, so let's take a look then at how we would do this. So f inverse prime is equal to 1 over f prime of f inverse of 4. So that's what we just developed. Now, f of negative 4 is equal to 0. This is true if and only if f inverse of 4 is equal to negative 4. So this means f inverse of 4 is equal to negative 4. Okay, so I now have 1 over f prime of negative 4. Well, that's something I can actually compute because I know that f is equal to 4 minus 3x to the 1/2. So f prime is going to be 1/2 4 minus 3x to the 1/2 minus 1, negative 1/2, and then times the derivative of the inside there, so times the negative 3, or negative 3 over 2 square root 4 minus 3x, if we wanted to clean that up a little bit. And so this tells me that f prime at 4 is simply going to equal subbing in 4 into this derivative function. So let's see what we would end up with on that. I'm sorry, I'm subbing in negative 4. Subbing f prime of negative 4. Sorry about that. So this is subbing in negative 4 right there. All right, that's a good thing because otherwise my square root would have been negative. So this is going to be negative 3 over 2, and then the square root of 4 plus 12, so root 16, of course, is just 4, and so we end up with negative 3/8. And so we now have, I'll just say, circle that a little bit, maybe put an asterisk by it. So by below here by asterisks. This is going to be -3/8. F prime of -4 is -3/8. And of course, 1 divided by -3/8 is like multiplying by its reciprocal, and so we get -8/3. All right, let's look at maybe one more, number 2. So number 1, I think, is probably how I'm more apt to maybe phrase a problem. Number 2, I'll take one a little bit more from your book's phrasing. And they may say, if, oops, here we go. So this is more like your book's phrasing. If f of 0 is equal to 3, and f prime of 0 is equal to -5, so this is right from a homework question actually. Let's find g prime of 3 given that f and g are inverses or inverse functions. All right, so your g prime at 3, so let's go ahead and write that out. So your g prime at 3, or if you were me, you would write it as 1 over, I'm sorry, you'd write it as f inverse prime at 3, but I'm using this one more the book's notation. So this is going to be 1 over f prime of g of 3. So that's using more of the book's notation. All right, so if, see, I hate this. I find this very awkward to use. I'd rather use the inverse notation, but let's go ahead and finish this out using the book's notation. So I need to know what g of 3 is. So here's what I know. So we'll come down here and say if f of 0 is equal to 3, that's going to be true if and only if g of 3 is equal to 0, again, because f and g are inverses. That's why I would just rather write it out as inverse notation. But that's what we end up with here. So this is going to be our result that we put in here for the g of 3. And so now we're looking at 1 over f prime of 0. And f prime of 0 was given as -5. So our answer on this one is -1/5. All right, so there's just a couple little questions. You might see a couple, not really a huge issue we're going to spend a lot of time on. So next time we're going to come back, we're going to recap a little bit something about domains and ranges of inverse trig functions and their inverse trig functions, and then we're going to get into the derivatives of the inverse trig functions next time.